Hey, I'm Andrew Jordan.
And this is Jack Carter.
Coming up next is a documentary of our 2007 science fair project, the Hovercraft.
Our show begins with the construction of the deck, or base of our hovercraft. Step 1 of our hovercraft. This large piece of plywood will be used for the base of our hovercraft.
So then we're going to cut it, and we use Pythagorean theorem to figure out what dimension this line would be on the base, and we also use it to figure out what dimension these lines would be down on the bottom. After a few measurements and cuts, we had the basic deck for our hovercraft, and we began attaching the original skirt. Here we have our impervious nylon, which will be used to build the skirt of the craft. We chose this because it won't let water or air through it, and it's a thick, durable material.
Our skirt, we're going to cut a strip out of here and attach a drawstring through it, and we'll get the curvature of the craft so that it will be able to float easier. And we need the curvature because if the skirt were flat on both sides, it couldn't get the air to stay in. It would just pass by under the skirt. So the curvature is very important in the craft. This is the finished product of our skirt. It's 20 feet long, and it will look like this with it encircling our hovercraft.
This is the drawstring. This drawstring is what allows us to adjust the curvature of the skirt once it's on the craft, which will determine how well it floats.
It acts like the drawstring on a sweatshirt, like the ability of the drawstring to close my face up, like that.
This is the finished base of the hovercraft. This is actually the bottom side of it. We painted it white and flipped it over. And next we will attach the skirt using these metal pieces of carpet trim.
We're going to pinch the skirt under there and make it airtight so that no air can escape. And we're almost complete with cutting them right now.
We were afraid that the points at the end of these metal pieces were too sharp and they might tear the skirt, so we decided we were going to grind them down so they wouldn't do that. This is a piece of the carpet strip with the holes drilled into it, and this is the bolt that we'll use. Basically, it goes like this.
Go ahead.
Now we have attached the skirt to the base of the hovercraft using our carpet trim pieces and several bolts. The skirt is pinched between the base of the hovercraft and the carpet pieces. Our next step is to flip the craft over and put in the remaining bolts to seal hovercraft air, and then we will cut a hole in the center and attach the blower, and then we will be able to decide whether or not we have completed our hovering task.
This will take. Now we're cutting a circle out for this, and Mr. Jordan's going to fit the blade in as our next step. And to make it airtight, we used weather stripping. It's made of foam, but the air can't get through the foam because it's made so the air doesn't go through. You need a washer?
Yeah, and now we just have to tighten this band and be ready for a test. This is our initial test to see if the craft, just the base of the craft hovers. We need to adjust the drawstring to get the curve. I think that's the problem. Okay, this is test number 2.
At the beginning, on our first skirt, we realized that when we pushed the long sides of our skirt in, that it would hover more successfully than it did before. And after that, we decided to tighten the drawstring even more, and that would make the curvature even greater, and it was even more successful after that.
The third test was much more successful. As you can see, the craft hovered by itself, but when stood on, all of the air slid out from under the sides and it went flat again. Upon some more tweaking, we were able to glide the craft easily across the floor.
We found that one of the most important aspects of getting the craft to hover was making sure that the point of contact of the skirt and the ground was underneath the base of the hovercraft, like on the inside and not on the outside. Otherwise, if it was on the outside, the air would just escape under, but since it's on the inside, it bounces around in there and it can't get under. And we noticed other problem areas, especially the corners, and we had to tweak those as well. During our testing, we noticed that the board would curve in like this, with the front being at my left elbow and the back being at my right elbow. And we would consistently have to push in the sides of the skirts, and after we did that, it would rise and be level. So Andrew will explain what we're doing to fix that problem.
What we're doing is we are mounting 1x4s running down the craft, and we're screwing it in, so hopefully the next time we start up the blower, it will prevent the craft from blowing like this, and it will float more efficiently.
There's a screw right under here, and it's not flush. Should I just make it flush right now?
Yeah. Adding the 1x4s to stiffen the base of the craft was definitely a very successful move, but our next step was to create some type of propulsion device to move the craft forward, and also a type of steering system. To do this, we originally started out with my dad's electric shop fan. We're mounting a brace on the propulsion unit so that it doesn't sway like this.
As you can see, our fan can turn. To control the fan, we're going to mount strings to each side. To go right, you would pull your left arm and it would turn the fan this way. And to go left, you would pull your right arm and turn the fan this way. Actually, as it turned out, I had those direction backwards. The craft ended up turning the opposite way because the fan was on the back of the craft and not on the front of the craft. If it was on the front of the craft, I would have had it right.
We did not realize that his directions were so messed up until I started driving it for the first time.